Hello, this is Ed and welcome to my channel. Today I'm going to show you how to use C++ threads. Threads have become available to C++ since the new standard of C++ 11 has become finalized. So I'm going to show you how to use threads in their basic form. I'm not going to do something complicated. I have been using threads a couple of times during my professional life, so I think this concept can be learned only by experience. So you have to create applications yourself and try what would happen. I'm just going to show you something basic. So let's get into it. So I'm going to create a special directory for our project. I'm going to call it C++ threads, probably like this. I'm going to put a number at the end of the name because probably I might make another tutorial about that. I don't know, just for future considerations. So let's make it 01. Now I'm going to create a main C++ file. So let's say it's Jesus Christ. Yep. So now I'm going to create a yep, that's it. So let's see if it's there. Okay, so we have a file now. I'm going to create a makefile for that as well, because yeah, alright. So now I'm going to use an IDE for that, because now I usually use Nano for simple text editing, but if I need some IDE to create some major projects, I usually find code blocks a very convenient IDE. So nope, not like that. So I'm going to do this. Yep. Alright, so what are we going to need? We are going to need the streams library, so I'm going to include the IO streams. We're going to need the vector library because I'm going to create many threads and I'm going to place them in a vector structure. I will use some algorithms, so I'm going to include the algorithms header as well. And of course we're going to use the threads library, which is thread, and there is a structure called mutex, which means a mutual exclusive access. I'm going to use that structure too, which has a separate file for itself. So I'm going to include that. I'm going to explain mutex a bit later. So I'm going to stay at the standard namespace. Now, what threads actually do is that you create a task and you assign a thread, special thread for that task, so it executes separately from your main workflow. Okay, so supposedly you have a GUI and you have some function or some method that contains expensive computation, okay, that might take, for example, 10 seconds or even more, okay, and if you, for example, click a button and your method executes, then you are going to freeze your application until that function or method finishes. Well, until that process gets finished. You don't want that, actually. You want to stay responsive. You want your GUI to stay capable of doing other things. Supposedly you want to interrupt the whole program and exit that, okay? Or maybe you want to load a file or anything. In that case, you want to have your GUI responsive. Well, this is one explanation why you need threads. Other explanations contain the improvement of performance, okay? Because instead of doing one thing at a time, you can use your processing power, which can include many CPUs or many cores that you have on your system. So when you create threads, you actually sometimes, if you do that properly, okay, then you improve the performance of your software. So back to the basics. I'm going to create a simple function, and I'm going to execute that simple function in a separate thread. Actually, I'm going to execute many copies of that function in separate threads. So for that purpose, I'm going to create you all know the factorial function, so I'm going to reinvent the wheel, as they say. So I'm going to create a factorial function which takes an unsigned int n, and you know that if n is less than 1, then I'm going to return 1, or if n is anything above 1, including 1, then I'm going to return n multiplied by factorial of n minus 1. Okay, so like if you, for example, have 5 for n, then you will start by multiplying 5 by factorial of 4, and factorial 4 will multiply 4 by factorial of 3 until you reach a point where n is less than 1. In that case, n will return 1, and that's it. Okay, so you'll have a string of a product. You'll have a long product like 5, 4, 3, 2, 1, etc. This is basic computer science, so I'm not doing anything difficult. Now, I'm going to define something called mutex, which I've mentioned before. It is of type mutex, and I'm going to call it my mutex. What a mutex does, a mutex make you access a place in memory exclusively. So, okay, supposedly you have two processes, okay, and both processes want to access a place in memory, but supposedly that the first process just reads a variable from that memory and starts doing something with that. But by that time, the second process probably accessed that same place in memory and replaced that variable by something else. Okay, so supposedly you have an online store, and you have received like 5 orders, okay, and you know that you have 5 orders placed, and you start working based on the fact that you only have 5 orders. But by the time you start like processing your orders, someone else probably places more orders in your store. So probably by the time you finish 30% of processing of those 5 orders, you have already 15 orders waiting. Okay, so well, this is probably not exactly the best explanation, but what you want to do is that you want to forbid anyone from accessing a certain place in memory until you finish doing what you want to do with that place, with that variable. Okay, so why I'm going to use a mutex here, I'm going to show in a minute. So now we need some driver function, and I'm going to call it exactly driver, and I'm going to take that n, or probably it's, well, okay, well, I'm going to receive that n, which stands for the, in that case, for the number of factorials I'm going to compute. All right, so I'm going to compute the result, which is factorial of that n now. That is I want to output that result. Okay, so actually what I'm going to do is something like that: cout get me n, get me which is n factorial equals, right? So it's result, and this is what I want to do, but actually it won't work. Now, why it won't work? Because by the time I'm going to access the standard output, okay, supposedly I'm just accessing the standard output, okay, at that time another thread might just want to access the standard output, and it might create a garbage in my results. Okay, that's why I'm using the mutex. Okay, the mutex here makes the access to the standard output exclusive to each thread. Okay, there is something called a lock guard in C++11, which means it locks the variable you are dealing with. So if I'm dealing with cout now, then I'm going to lock that cout under a mutex. Okay, so it's a lock guard, and it takes standard mutex, and it's a variable. Okay, so I'll name it guard, and I'm going to take the mutex that I have defined above. Okay, because this mutex, my mutex is a global variable, so in this case that's enough. I'm not going to make anything complicated, so I'm just going to use a global variable, happen to be a mutex, and I'm going to control access to the cout using that mutex. Okay, so this code now is safe, because now I'm not going to see garbage on my cout. Now every thread I'm going to declare is going to wait its turn until the cout variable is free to use. Okay, so the guard will lock the cout, and you will each thread will write its output, which is this variable result. Okay, and after that it will release the cout, which is mean the lock guard will go out of scope and it will get destroyed. So there is no problem in that case. What I'm going to need, yeah, I'm going to need a mechanism to tell the threads to join. Usually, if your main thread needs the other threads to complete before it exits, then it has to specifically tell them that, okay guys, I'm waiting for you to finish, please finish your job and come to me back. Okay, some tasks, it depends on the type of tasks. Okay, some tasks need to for the main thread to join them. Well, maybe there is something that you need to figure out. Maybe you need to be certain that all your tasks are being done properly. In that case, you are going to wait for all your threads to finish. You probably might have other types of tasks that you wouldn't care about. You'd probably just start a thread for such tasks and tell the thread, okay, go do your job, go home after that, do whatever you want. Just start your task and go away. In that case, you call the such threads detached threads. So, which is any thread that you don't ask to join. This is an operation called join. Okay. So I'm going to create something, an operation that's going to take class T. Well, T is the thread type in that case. So I'm going to create the threads on the heap, because most probably this is the way that you're going to use your threads, but you can create them on the stack, depends on your project. Okay, I'm showing you what is probably most common. Okay, I'm going to call it join, and I'm going to receive a pointer T. Okay, so what I'm going to do, I'm going to ask the thread to join, and I'm going to return it. You probably might want to do something with it, so I'm going to return it. Since you are using like pointers, you need to take care of your memory. I'm going to create another operation. I'm going to call it I'm going to call it delete. Since I'm not going to return it, so that's enough. I'm just going to delete the thread and be with it. And I'm checking if there is a thread, if the thread is still live, then I'm going to delete it. And I'm going to assign null pointer to it. Usually if you are using modern C++, then you don't assign null or 0 to your deleted pointers. You use a special variable called null pointer because that's safer. So okay, so now we have deleted each thread, and now we are going to do the main program, which is our main function, which is int argc. While I'm not using any command prompt or anything, but I usually stick to the standard declaration of main function. Well, that's just safer. I like order anyway. So I'm going to return 0. Alright. So now I'm going to create the threads. How am I going to create the threads? I'm going to use a vector which will take threads as type, pointers to threads. and I'm going to threads list. Okay, so this is the structure where I'm going to place my threads. I'm going to take n threads, and we can now start by asking the user to enter whatever, like say input the number of threads to create, and I'm going to make the maximum number like 10 threads. So okay, so I guess okay, so I'm going to read n. So if, alright, just like simple error checking, if n is less than 0, then I'm going to make it greater than 0, and if n is greater than 10, I'm simply going to leave it at 10. Alright, now we can start shooting out the threads. So for int equals to 10, now I'm going to call as much threads as I have n. So until n, and I'm storing the threads. I'm going to call in my threads list push back, right? So now I'm going to create on the heap my threads, and for each thread, okay, I'm going to call the driver function that I have created. It's above here. Okay, I'm going to call this driver function to be executed in each thread. But since that driver function also accepts parameters, then I'm going to add my parameters here in the thread declaration. The thread declaration takes either static functions, or it takes function the object, how do you call it, function objects, object functions. If you have a class and if you have declared the operator of parentheses in that class, like for example operator, okay, then each class that has declared such an operator can be placed in place of this driver function. Okay, I probably might do another tutorial on that, but for now let's stick to the basics. Alright, so I have the driver function and I need the parameters to that driver function. In that case, I'm going to use I. Okay, it's just for illustrating purposes. So I'm going to send to each thread. I'm going to create a driver function with a different parameter inside it. Okay, so once I'm going to create like factorial of 2, the other time I'm going to create start a thread with a factorial of 5, etc. You're going to see. So going to make, well, since this is starting from 0, then I'm going to make I go starts from 1, right? So okay, this is the place, this is the moment when those threads really start. Okay, so now they have started. Okay, they are now running. Now I'm going to ask them to join back. Okay, you might want to do that, you might not. It depends on your task. But for me, for now, I'm going to check that those tasks have been completed successfully. In that case, I'm going to say that I'm going to use a function from the algorithm, which is transform. If you have okay. Why I'm going to use transform? Because I have one operation that I'm going to repeat for all threads. I have this operation which asking the threads to join. Okay, and I'm going to ask every single thread that I have created to join back. So for that purpose, I recommend users to use the transform operation from the algorithm header to apply such repeatable tasks. So I'm going to transform, and I'm going to tell the threads list from where to transform. So I'm going to call for a constant iterator because I don't want to modify the beginning iterator and the ending. Okay, and I'm going to apply that back on the threads list. Okay, and now I'm going to tell the transform function which operation to use. Here you can place any operation you have created depending on your needs. You can probably, if you have, for example, a vector of double numbers, okay, and you want to compute your square roots for that for those numbers, you create a function similar to this, and you call it, for example, square roots, okay, and for that purpose, you apply then the square roots on each number of this. For our reasons here, we are using the joining operation on threads, okay. So what I'm going to say is operation join, and I'm going to take a thread for that, which is okay, and that should be it. Okay, now I have asked all my threads to join back. So I'm going to delete the pointers. So I'm going to release them, which in that case I have to do something like this. I'm going to use the for each loop, which is going to loop for all my positions in the threads list. And it will call the operation delete. Okay, since I'm going to repeat that task, I'm going to do the same. Yep. So here you go. Okay, and that should be it. Okay, so I've created a vector of threads, all pointers to threads. I've asked the user to enter a number. I've created on many threads on the heap, and I've passed to each thread the driver function that is going to execute with appropriate parameters. And I've asked the threads to join back to the main thread after they have finished their tasks. And after that, I've deleted their memories. Okay, the occupied memories, or released them back to the system, and that's it. Well, actually, it's not exactly that simple looking, but once you have done something similar for a couple of times, it becomes really straightforward. Okay, you need to create a mutex whenever you need to access a global variable or a shared variable. Okay, because cout is a shared variable here, because your driver function is is being executed by many threads. Okay, so every variable that you have in such driver functions and such static functions, which are going to be shared by such threads, you need to guard by a lock. Okay, and you have to ensure that the access is mutually exclusive only. Okay, this is a join function and this is a delete function, so I believe this is it. So I'm going now to create a makefile, and let me see, did I create that one? Yes, I created that one. Come on, cancel. What did I just do? Yep, open. Select an external program, open it with associated application. Oh yeah. Alright. Oh, actually I can do it with Nano because this is probably better. So where are you? Yeah, here. So okay. So now I have this. And well, there is one thing that I have discovered. I'm going to tell you in a minute. Okay, I'm going to first assign the compiler this switch. Okay, I have discovered that I have to compile and link my multi-threading applications using this switch repeated in both processes. I mean the process of compilation and the process of linkage. Okay, so but I'm going to show you. So I'm going to use the C++11 standard, and I'm going to compile all warnings and pthread, and again I'm going to use the C11 standard. Alright, so now this is one target, which is going to generate me test, and test is dependent on main object, which will be dependent on cc main object, and it will output me, let me output it to some place called binary. It will be named test. I have to change the mode of this file so it can be executable. No, actually like this. Okay, so right, and main O is dependent on main cpp, which is flags. Okay, so this is the problem that I have discovered. If you want to create multi-threading applications using C++ standard 11, you need to include this option in both the compilation phase and in the linkage. So here I'm including it in the compilation phase. Okay, so I'm compiling and creating the object file, and after that, during the linkage phase, I'm also using this switch. Otherwise, it won't work. I don't know why. I just don't know why. Okay, I just discovered that, and I've googled the problem, and I have discovered the solution. So just don't forget to use that. Now I will need also a clean target. Which is phony. So in that case, I'm going to remove everything that is O, and I'm going to remove bin test. Okay. So I guess that should be it. So let me make a directory called bin here. Okay. So let's see what happens. Holy quack. What just had happened? Threads wasn't declared in this scope. Oh yes, it's thread, not threads. So oops, like that. So let me see. Okay. What? Oh yeah. Jesus Christ. Okay, so what I have forgotten here. Okay. Yep. Development phase, debugging. What a happy life. So let's see. Okay, now it works. Well, I mean, now it compiles and links. So let me see. Yep, it's there. So let's try it. Input number of threads to create, and I have maximum of 10. Okay, let me try 6. Here we go. So I have executed 6 separated threads, starting from each thread is computing its own factorial number assigned to, which the first one is 1, the second was in this order 6, 3, 4, 5, and 2. Okay, now here's one thing. If you call multiple threads to execute, there is no guarantee that you are going to execute your threads in that specific order that you have called. Okay, so in this case you obviously see that I have like started 1, the first thread, then the 6th thread, and after that 3, 4, 5 before the second thread. Okay, so let's try it again, and I'm going to put 10 in this case. Okay, so here you go. I have started the first thread, the second thread, the third thread, the 5th, 6th, 7th, oh, and the 4th. Okay, so the 4th started after that. Okay, then the 8th, 9th, and 10th. Okay, I can do it again. Let's say 4. Okay, in that order, that's okay. Let me try again 10. Okay, here you go. You have started the first, second, and fourth, 5th threads before you have started the 3rd thread. Then the 6, 7, 8, 9, 10. Okay, so this is a basic application of threads. This is the basic knowledge that you need to execute threads. Always remember to make sure that you are not going to access any variables simultaneously, unless this is necessary, and unless those variables are read-only. But since the cout is not a read-only, it's a writable variable because I'm writing to it. Okay, so that's why I need to guard it at all costs. Otherwise, I might get garbage. Okay, so actually, I'm not sure if I'm going to. Let me try this. Let me try this. Okay, let me try this for you, and let me say make clean. Okay, now let me say make. Okay, and let me access that function again. Let's see what happened. Here you go. You see that garbage? Because you started one thread and one of your threads wanted to write something out to that to see out, when at that same moment another thread came in and wanted to write something too, which causes the garbage. Okay, so here again you have another garbage. Okay, this thread wanted to compute, but it outputted garbage, and it computed later and accessed the cout variable when another thread was accessing it at the same time. Okay, so this is why you need to guard all your writable variables that you are going to read later, or want to write to. Okay, so unless you're not using read-only variables, please use mutexes and guards. And let me put back that piece of code. Here you go. Okay. Let's try again. And that's it. Now you have the right answer. And that concludes this tutorial. Hope to see you next time. Thank you.